Welcome to this video where we're going to look at the addition of fractions with related denominators. In particular, we're going to look at adding a half and a quarter and 1/4 By related denominators, I'm talking about fractions where we would only need to change one of the denominators to add them together. Adding fractions requires students to understand the equivalence of fractions. And secondly, it requires students to understand the difference between fractions as a number, in other words, fractions having a magnitude or a size, as opposed to fractions of quantities. So by that, a fraction of quantity, I'm talking about something like half of a rectangle or half of a quantity, half of 20, for instance, as opposed to a half being a number that we can place on our number line. So when we're adding fractions as a number. One of the biggest misconceptions that students have when adding fractions is trying to follow a procedure or a rule in regard to the denominators. As you would have seen in previous videos, I strongly recommend avoiding words like numerator and denominator when introducing students to fractions. The reason for that is we want students to see this numerical representation of a half as a number in itself, not as two separate numbers. And using language like numerators and denominators tends to get students thinking of their fractions as being two numbers. We want them to see it as a half. Often when students add fractions, they apply rules, and unfortunately, they apply them incorrectly. So we often see this as the result. And the reason is they don't have a conceptual understanding of what a half and a quarter is, and what we need to do to actually add those fractions. What we're going to do is come back to the rules. Of course, we want students to be able to do these problems numerically. But first we have to build the understanding of fractions to get them there. And it's worth investing the time. It is going to take longer. But we still have students 3, 4, 5 years into their education on fractions making these errors. So we need to spend the time initially to get that good foundation. If I had represented this problem in words, if I had said 1/2 plus 1/4, it's almost impossible for a student to come up with an answer of 2/6, because using the words is forcing them to think about what a half represents and what a quarter represents. If we go back to our number line, we have marked in 1 and 2 here, so we're showing that fractions go beyond just 1. And initially, students will learn to count in halves. 1/2, 2 halves, but we want them to start referring it to 1. So seeing the equivalence between 1 and 2 halves. 3 halves, but again, seeing it as 1 and a half as another way of representing it. And then 4 halves being 2. So skip counting, 1/2, 2 halves, 3 halves, 4 halves, but getting them to start introducing the whole number representation as well. 1/2, 1, 1.5, and 2. We then want to introduce them to quarters and seeing the equivalence between quarters and halves. And because these are fractions that they may frequently come across every day with things like sandwiches and so on, it's good to build the conceptual understanding with these common fractions. So 1/4, 2 quarters, 3 quarters, 4 quarters becomes 1/4, a half, 3 quarters, 1. So building that counting up. Now what we can see is that if we ask students to add a half and a quarter, they could physically do it by taking a half and a quarter and seeing where it ends up, 3/4. So they've taken a half plus a quarter and they've got 3/4. We haven't taught them any rules at this stage. What they're seeing is that is the physical result of adding a half and a quarter. Where do we head from here? Well, what rule would enable you to come up with this? What is the pattern that creates this? And what we need students to start seeing is that just like we replaced 2/4 with a half when we were counting, we can replace a half with 2/4. We couldn't replace a quarter with any halves. There was no equivalent representation here. But we can replace the half with 2/4. So what we're getting is 2/4 plus 1/4 to get the 3/4. How can we represent that numerically? Well, we had 2/4 plus 1/4 equals 3/4. No talking about rules there. How can we take this further? Let's have a look at 1/2 plus 3/4. Again, 1/2 plus 3/4. We're not going to see them follow that misconception when we use words to make it 4/6 because we don't even mention sixths down here. We can add 1/2, unfold to make our 3/4, and we can see that we're landing on 5/4 here. How can we talk about the same thing here, the same quarters? Well, we can't replace our 3/4 with halves because there's no representation here, but we can replace our 1/2 with 2/4. Now we can do that again with other fractions, not just our halves and quarters, but we could then move to our eighths. And again, if we asked a problem or a question like 3/8 plus 1/2 equals, we can then start getting students to see if there's another representation for eighths here. So we have our eighth, and we can mark each of our eighths on our number line. What we would want them to look at is where is the 3/8? Can we change that to any halves? No, we can't. So we need to leave it as 3/8. Could we replace our half with anything? Well, it was 4/8 if we'd labelled it on our number line. And now we can see that it's 7/8. We can check by taking our half and adding 3/8. It's 3/8 plus a half, and we can see it arrives here where we would have labelled 7/8. So a couple of things to take away from this video. Introduce addition of fractions with different or related denominators by using words first, before you use the numerical representation. Represent your fractions on a number line, as well as having your area models. Notice I use thin rectangles rather than circles for my area models. I find them easier for students to partition. Circles are quite challenging to get a fractional amount of. So I would definitely start with rectangles and refer to chocolates rather than pizzas. They need to understand that the fractions themselves are a number, that they have a magnitude, that we can compare that magnitude of different fractions, and be familiar with skip counting of their fractions, moving into skip counting of their fraction, changing it into equivalents. So 1/8, 2/8, no, let's use 1/4. So 1/8, 1/4, 3/8, 1/2. And from there, making each of their sums or their problems, physically seeing where the answer is. They could have estimated where they thought the answer would be, and then deciding which of the fractions they should change. The students themselves will start to come up with how they would convert. And in fact, with related denominators such as 1/2, 1/4 and 1/8, or if we then moved into fifths and tenths, if we do thirds and sixths, with those related denominators, we really want students to have a feeling for, or even a memory for, what the equivalence is. We want them to know that you need 2/10 to make a fifth, that you need 2/6 to make a third, without necessarily going through a rule or a procedure to get there. I hope this helps build understanding with your students on how to add fractions with related denominators. If you haven't checked out our previous videos, please do so. And if you can, please hit subscribe or leave us a review. We'd love to hear how this work's going in the classroom. And please post any questions that you have. Thank you.